Now, what I've done, oh well, come on, sit down. Oh, let's see. You're coming from Emer's class now, aren't you? No, well, some people are just coming in now, yeah? Mahmoud? Ghaffar? No Ghaffar? Oh, so you might show up? Okay. Oh, well, look, I'll just wait a couple of minutes, so we'll get started now. Because what I want to do, I want to finish binomial hypothesis testing and then go on to goodness of fit, chi-squared, on the next page. So, with the group this morning, which group number are you? You're 1. Okay, so with group 2 this morning, I did questions 1 to 11. However, I realised I screwed up number 11, so I'm going to start from 11. You can watch the video, you'll get the solutions for 1 to 10. It's already uploaded. Now, I'll just tell you from doing 1 to 10 that the answer for number 9 at the back is wrong, but it's wrong not for the reason you think it is. There's actually a mistake in the question. And I think it's worth talking about number 9 before we start at 11. So number 9, can you see it there? A fortune teller claims she can predict whether or not a person is thinking of a cat or a dog when asked to think of one. A researcher tests this by having her predict what animal 10 people are thinking of, and it was found she was right for 7 of the predictions. So, what hypothesis are you testing here? That's all I want you to tell me. What's the null hypothesis? Yeah, as a number. What exactly? Yes, that the probability that she predicts is 0.5. And the alternative? No. More than 0.5. I did, by using the word predict. So when I say, guys, just think about it, like, come here, look, I flip a coin, and I claim that when I flip the coin, I can predict what will come up next. If I'm right 50% of the time, does that make me psychic? No, why? Because just by dumb luck, I'll be right 50% of the time. So if I'm claiming I can predict, I need to be right at least 50%, but really I need to be right more than 50% of the time. So if I could predict 60% of the time, 70% of the time, then it means I have psychic powers.
Is it the alternative 100%? Because she's saying she can predict every time.
Usually when we're talking about this in statistics, the word predict, I know what you're meaning, like predict means you get it right all the time, but in statistics the word predict, if you say something has predictive powers, it means it's right more than just dumb guessing. Okay? That's what we mean when we say predictive powers. So another famous example is something like, it rains 5% of mornings. And I say I can predict the weather. If I just say every morning it will rain, then just by dumb luck, or not even by dumb luck, just by averages, I'll be right 5% of the time. So you can only believe that I can predict the weather if I'm right more than 5% of the time. So for this, the null hypothesis is that she's right 50% of the time, and the alternative is she's right more than 50% of the time. But this is wrong. Yeah. But why is this wrong? What are you assuming that I never said in the question? There's something I never said, and you're all assuming it in the question. Read the question again. Well, anybody figure it out?
predict directly.
No. No, it's implied in the word predict. There's something that you're all assuming, and I think the Muslim students should figure it out first, if you can believe that. Of course, my non-Muslim students can figure it out too. I thought the Muslim students might figure it out first.
It's not possible to be psychic?
No, all students can believe that, not just the Muslim ones. Something else. No. Okay, I'll tell you now. So, I'll tell you now. The mistake everyone is making is everybody is assuming the natural rate at which people pick between dogs and cats is 50-50. This is not true. I think if I went to a Muslim country and I asked 10 people to think of a pet, it'd be more likely that they think of a cat than a dog. So, in fact, it's possible that this could have been 10 Muslim students, and the psychic just said, you're thinking of a cat, that's your pet.
So the type of people that
Yeah, so what you need to know is what is the underlying rate at which people would pick cat or dog. It's not necessarily 50-50, you know. And this is actually really, really important because there's an example here. I wonder if I can find it.
Is this the only question that the answer was not correct on the
No, I think my for 11 and 12, my calculations were wrong. So but this is the only one where it's wrong in the sense that
Nothing before 9 was wrong though, yeah?
no, we calculated all the right answers.
You sure?
Well, I didn't check, but I flicked back and checked as I was going for most of them.
There's no question over it.
Which one do you think is wrong?
I'll look through the video then I'll come back.
Okay, fine, yeah. Oh, I can't.
Look for it.
I can't find it. It's no. There was a star in it. Oh, it's something like this. It's not quite this one, but it's something like this. So what you do is the psychic says, "Oh, look at a card. Think of a card. Which card are you thinking of?" And then the person then says it. And if they're psychic, they should be right more than what percent of the time?
More than 0.5.
No, not in this situation. Look at this situation. 20% of the time. You know, if you have 5 cards, then there's a 1 in 5 chance of just guessing the right answer. So if the psychic is right more than 20% of the time. You know. But the problem is you're assuming that people pick between these equally likely. Whereas I think it's something like people more often pick a star. It's something like, 40% of people will pick a star when presented with these 5 symbols. So if the psychic simply says, you're thinking of a star, then they'll be right 40% of the time. So it looks like they would pass the hypothesis test. They don't really, because you were assuming wrongly that people pick these equally likely. So anyway, I just wanted to show you that one before we go on to number 11, which is quite hard. So 11 here.
Could I just comment?
Is it a comment that will positively contribute to our discussion?
That's a question.
Okay, go on.
So, I know that there are 5 possibilities.
Yeah.
But there are only 2 answers. It's either right or wrong. Isn't that 50% chance?
No. Think of a number between 1 and 100. You thinking of it? Don't tell me it.
Okay.
Don't tell me it. Is it 17?
No.
No. Did I have a 50-50 chance of being right? Because I could either be right or wrong. Okay. 11A. This one is quite hard, and I screwed up the calculation with the previous class, so we'll go through this one. A farmer is testing a new seed. He tests a sample of 20 seeds to see if the new seed is better than the old seed for germinating. Typically 75% of his seeds germinates. So what's happening here is he buys some seeds. And he was expecting, if he has 20, how many should germinate? If it's 75% of them. Come on. 15 should germinate. Okay? But he wants to test the hypothesis that the probability of germinating is more than, null is equal to, and the alternative is that it's more than 75%. Okay? So he tests out the new seed. He's wanting to see more than 15 germinating if he's trying to test the claim that it's a better seed, right? So the question is, at what point does he have enough evidence to conclude, yeah, this is a better seed? So this question is the opposite. We're working backwards, p-value. So let's take the most extreme possibility. Imagine all 20 of his seeds germinated. Do you think that's evidence that it's a better seed? Yeah. Like, this is the most extreme and convincing possibility. We start to reduce down, and at some point, I'll call it X, we reach a critical decision where we get exactly 5%. And if we go past this number, then we don't have enough evidence. So obviously, imagine we went as far as 16. Do you think that's convincing that it's a better seed? No. So there's some point here where it starts flipping from being convincing to unconvincing. And we know from definition that that is at the 5% level. Okay? So we are looking for the answer to be 5%. So we want the probability of X or more germinating to be 0.05. Perhaps, let's see. Now, the problem is we have X or more. Can we look up or more? No. No, so that would be 1 minus the probability X or more. What's the opposite of X or more? Now, this is hard because I don't have numbers.
Less than
X minus 1.
It's how many seeds does he have? 20. 20 minus X. Is it? Oh my goodness, this is difficult.
You wrote the question.
I know I did. Let's just put in some numbers so we can practice, okay? If I said 17 or more, what's the opposite of that? 16 or less. How did we get 16 or less? It was just one less, wasn't it? Like if I said 18 or more, then that's the same. That's the opposite is 17 or less. So it's X minus 1 or fewer, yeah. Germinating. Oh my goodness, I already don't like, why did I do that? Okay. Oh no, I know why I did this, because I saw this in the exam once, that's why I made this. Okay. Right. So, can we look up this in the book? No. The problem now is, what's the probability of germinating? 0.75. Yes? But what's the limit we can look up in the table book? The biggest probability is 0.5. So what's the trick here? Yeah, we have to state it not as how many germinate, but how many non-germinate. So, no. So, if I said, let's practice again with words, 17 or more germinating, how many is non-germinating?
25 or less.
No. 3 or less.
Yeah.
17 or more germinating, that's the same as saying 3 or fewer not germinating. So it's a flip around. 20 minus the previous number. So that's the probability of 20 minus X minus 1 or fewer not germinating equals 0.05. So that means the probability of 20 minus X plus 1 or fewer, not germinating, is 0.95. So that means we have to go to the table book. We have to go to the table that has n is 20. We have to go to probability of 0.25. And we need to find the number here so that we get an answer of 0.95. So, let's grab our table book.
What page is it answer?
I'm looking, where is it? Where's the table with 20 on it? Page 12. Okay. 20, 0.25. How far down can we go before we get to 95? 8. 8 is good. 8 is good. Okay. So that means this number here, which is this number here, is 8. So 20 minus x plus 1 equals 8. 21 minus 8 equals x. So what's that, 13? Is it? No, something's gone screwed up here. It's not 8.
Shouldn't it be more than 3?
Is it 5?
Hang on, maybe I'm reading this wrong. Am I at 20? Yes. 0.25? Yes. And I want 0.95, don't I? That's 8, isn't it?
8.
It should be 0.05.
Yeah, this is the opposite.
No, it's... If germinating is 75%,
Yeah.
then not germinating is 25%.
Yeah, but we switch the opposite? Did we
Is
switch
1
it?
minus.
Because we do 1 minus.
Yeah, so that was 0.05, so I took the one over already.
Yeah, but now you're looking at
Oh.
fewer, not
Wrongs.
not germinating and fewer,
Yeah.
instead of more and germinating. So don't you take the 5%?
What did I not change?
The probability before you subtracted the thing from 1.
Here? Hang on, let's just start from the beginning and then we'll check each step, okay? Right. No, focus. This is hard enough. Right. X or more germinating needs to be 5%. That's okay? Right, X or more germinating. Oh. That's
Correct.
1 minus the opposite of this. And the opposite of X or more germinating is X minus 1 or fewer germinating. That's correct, yes? Okay. Now, what did I do here? I changed this into a statement about germinating to not germinating. Okay, so if I say X or 1 fewer germinate, then that's 20 minus this number or
Or
more, isn't it? It should have been or more. Flip's sake. Sorry. But you can't look up or more in the book, can you? So you have to 1 minus that. Why? 1 minus... Okay, so I'll just take it up from this line. Right. I don't want this 1 here, it's annoying me, so I'm going to take that to the right. So I get probability of 20 minus x minus 1 or more germinating. That should equal 0.95. But you can't look up or more. You have to look up or less. So this is 1 minus the opposite of this.
Yeah, so it's back to 0.
So how do we flip, like, for example, 17 or more? That would be 16 or less. So we have to do 20 minus x minus 1 or fewer. That's equal to 0.95. Goodness sake. Right, so that goes back to 0.05.
Yeah.
20 minus plus, the ones cancel. So that's 20 minus x or fewer. So now, table book, 20, 0.25, some number equals 0.05. What number is that?
Five.
Is it? 20?
It's
0.25? It's only 1. 1. You're a little too big if you go to 2. It's only 1. Yeah, so this number is a 1 here.
Why is far away from the...
No. So what's the x here? X is
Wow.
19 then. Okay, I know that was very, very difficult, but I mean it was one of the questions near the end of the worksheet. So what does that mean? That means the farmer needs to get 19 or more seeds germinating before he's convinced that the seed is actually any better. This seems reasonable, doesn't it? Like, if he got a new seed and 16 or 17 or 18 of them germinated, then he might think, well, it just happened by chance. Maybe it's not a better seed. But if he starts getting 19 or 20, well, now he's starting to think, actually, I have evidence that this new seed is better than the old seed. So 19 is the point at which his mind gets changed. Yes, Amjad?
What happened to the 1 minus?
Which one minus? This one minus? I took it over to the 0.95 and it became 0.05. Yeah. If that's the only thing that confused you in this question, you're doing well. Okay. Right. Now that we have our mind a little bit around this, we can practice another one with B.
I got continuously more lost every time you start from more to fewer.
I know.
More to more.
I know.
More to
This is the hard thing about this question, is manipulating it into a value that you can look up in the table book. Now the good news is in the exam, they tend to give you numbers in such a way that you don't have to do many of these mental flipping around. You know, for example, maybe the germinating rate was 40% instead of 75%. Then that gives us one less thing to flip around. Do you know? Yeah. Okay.
But only flip twice here, and B, you kind of have to do it more.
Yeah, well, I had to flip more than twice because I screwed up, so I had to go back. You know, I suppose if you did it right the first time, it would not be many flips. Let's try and do it right the first time in 11B. Can I scroll down? 11B now. So it's exactly the same info, except this time you're not testing that it's better, just that it's different. So once again, what's the null hypothesis? The probability it germinates is 75%. And what's the alternative here? Not 75%. Because, after all, he would like to test that the new seed is simply different, which means it could be worse. So before we start, how many would have to germinate to have him convinced this is doing the same thing as before?
Anything plus 15.
Yeah, oh no, if he wants to think it's doing the same thing as before. 15. Okay? So, what would be extreme? What would provide evidence to the contrary? Evidence that it's not 75%? Well, if he got very large values,
No.
you know, like 19, 20 and so on, or very small values. Okay? So there's some number here, and there's some number here, where he decides, you know what, this is so many, it's different. Or, this are so few, it's different. Okay?
Didn't you already find that in the last question?
Not quite. Not quite. Because what's different this time is that p-value of 5% is now shared between the two extremes, here and here. So this is 2.5% and this is 2.5%. Now you are right though, all the calculations for this part are the same, except there's only one difference. Instead of using 5%, you're using 2.5%. So if you jump to the last step, what is the only number you change?
1.
this one. Instead of being, yeah, divide by 2. However, because of my choice of numbers, if you actually look up the table book, what value do you get? You actually still get the same value. Because, if you look it up here, the first value, x is 1, will do. Can I use x is 2? No, it's too big. You see, it's 0.0243. So actually, just out of coincidence, you get the same answer here. That this guy is still going to be n is 19. So 19 or 20 will do for this extreme. So what we need to calculate is the left extreme here. Okay, so let's calculate that now. Now that's actually easier than the last one. Well, I say that now, but we'll see, I suppose. Okay. So we want the probability of m or fewer germinating to be 2.5%. Okay, this looks good because we can look up or fewer in the table book. What's the problem here? The germinating probability is 75%, which we can't look up. Right,
So
yeah.
one more less.
Yeah, so again, let's use some numbers to make our mind clear. If I said 2 or fewer germinate, then that's the same as saying what? 18 or more do not germinate. So that's flipped around as 20 minus m or more germinate. But the problem is we can't look up or more. So we have to do not. 1 minus. Now, let's just again practice here. If I said 6 or more, not germinate. If I said 6 or more, not germinate. What's the opposite of that? 5 or fewer. So this would be 20 minus m minus 1 or fewer do not germinate equals 0.025. So just rearranging this, I'll get 0.975, right?
Yeah.
Equals, now we have to go to our table book, 0.25, and we need to find some number here that will give us 0.975.
I think that's
0.25.
Sorry, yeah.
9. So it's going to be 8 or 9, right?
It should be. 8, 9 is close.
You think 7?
No.
Am I looking at the right one? 0.25, yeah.
And then you go down.
20, and you go down until you get 0.975.
Yeah, 9 is the closest.
Yeah.
Yeah, but it's a little bit over, isn't it? So we need to decide between 8 or 9. Now, I'll help you decide, okay? So, not this, okay? I'll help you decide. So, if you were to choose 9,
No, it's
where's it gone? Sorry, 8.
yeah.
No, 9. We're trying to choose between 8 or 9. I want to see what happens if you choose each.
9 is over 8.
Yeah, 9 is over. So, you know what? To make it really crystal clear, for the moment I'll just write 8 or 9, and I'll show you the two different answers, and then we can decide. So the first possibility is that it's equal to 8. So that means 20 minus m minus 1 is equal to 8. Or 20 minus m minus 1 equal to, did I say 8 or 9, or am I saying 7 or 8? Sorry. 8 or 9, okay, thank you. Right, so what's the m here? That's 19. 19 minus 8 is 17, isn't it? And here, this is 19 minus 9. This is 16, isn't it? Okay. So, just think about what we're trying to do. We're trying to find a point at which he becomes convinced that that it's different. So, if you had to choose, which would be the more conservative choice?
There's something wrong, sir.
Is
Yeah.
Because isn't this the minimum value, the smallest value? Shouldn't
so
have
isn't
been.
it
Oh, sorry.
then
Did I do something wrong here?
isn't it then when you put 9?
Sorry, I forgot how to add, did I? I'm very hungry. What's M here? M is 20 minus 1. Minus, I was way off. 11, and here it's 10. Okay, sorry. So, you want to be conservative here as a researcher. Think about it like this. Which situation would, you know, put the burden a little bit higher for the person making the claim? You know, imagine you're the farming company who are selling this new seed. Which one would be more burdensome for you? 10. Yeah, because that would be more. Yeah, it's more conservative. Yeah. Now that's one way to think about it. Another way to think about it is if you were to choose 11, then you wouldn't get 0.025 here. You would get a little bit more. And you always want to be a little bit under to reject the null hypothesis. Go back to the start here. What's the null hypothesis? That the P is 75%. Do you want the farmer to reject this? That means your P value needs to be at most, but really less than 2.5%. So if you were to choose this number here, you would be smaller P value. It's less likely to happen because you're further away. You know, so in other words, if you had a choice between rounding, you should choose the one that's further away. So the answer is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 19, 20. If he sees this many germinating, then he's convinced the seed is doing something different to what his previous seed was doing. Now, obviously, he would prefer to be at this end. But, you know, it's possible that the new seed is worse. And he would conclude that, you know...
If the data has preference, so why would you split the critical value into equal parts?
No, but this one is not preference. This one is just that it's different. The previous one was preference.
So you picked 9. 9 is better.
Huh? No, 10.
No, I mean the table value.
Oh, yeah.
9.
Yeah. Okay. So that's very difficult. If you go to number 12, I'm not going to do number 12 because number 12 is the same as 11b. I just changed the story, but the numbers are the same. Can you see that? In a school of 20 students, so the seeds have now become students. Most of them passed. 75% of them have passed. So passing has now become the new germinating. And the new teacher joins. The principal would like to know if the teacher is affecting the pass rates. So why is that like 11b and not 11a?
Because you don't specify.
I didn't specify that the teacher's doing a better job, just that they're doing a different job. Yeah. So the answer and the calculation is literally the same. So we'll just do number 13 and then we'll go on and look at maybe whatever you found difficult in the goodness of fit. Although I think the goodness of fit is easier than this, right? Yeah. 13. In the general population of Ireland, it is known that 10% of people have blood type B. A random sample of 20 people were drawn from a subgroup of Irish people, and it was tested and noted that 5 of them have blood type B. Test and report this. Okay, that's actually just a standard question. I think what I'll do is just move that up earlier. Anyways, right, what's the hypothesis here? That the probability of having blood type B is 10%, and the alternative? It's just not, isn't it? not 10%. Okay, and how many people did I have? 20, and how many of them had it? 5. So the p-value is equal to...
What
So-
does the green eyes matter in this? Like,
It doesn't, I'm just trying to confuse you. Right, so what is extreme here? There's too many people here with blood type B, isn't there? Like if you had 20 people, how many should have blood type B? Come on. 2. If you have 20 people, 2 of them should have blood type B. And how many do you have? 5. So what is more extreme? So you have 2 with blood type B, but actually you had 5 with blood type B. So more extreme than this would be 5 or more.
Where did you get the possibility?
Which one?
10%.
Says it. In the general population of Ireland, it is known that 10% of people have blood type B. You know? Or TFQ. Yes? You know this abbreviation? Or TFQ? Yeah. Right. Right, okay.
Do we need to know?
No. 5 or more. 5 or more would be more extreme. Okay. But you know, actually, looking at this, I think I know why I put this at the... Let me just cancel this. Mechanic, I think. Right. What was I saying? Oh yeah, so I think I'm not happy with the alternative being not 10%. I think what you're really testing here is that there are more people with blood type B in the green-eyed group. Okay, so I actually think the alternative should be that it's more than 10%. See, I didn't say this in the question. I wanted us to have a think about it.
or why not? Yeah.
Why not what?
Why not less than 10%? Why greater?
Just imagine that you're a researcher for a moment and you know that 10% of people have blood type B, and then you're looking at some particular subgroup of people. Maybe these are people who have green eyes, or maybe these are people from another country, and you're looking at it and you say, oh, there's a lot more people in this group with blood type B than what I thought there should be. So what you really want to know is, you know, is that true? Is this population having more blood type B than what you thought? So it's not that you're testing that they have a different number of blood type B. Really what you would like to know is that is there more people that have blood type B?
So if you have people less than 2, you
Yeah.
already have 1 or not.
Yeah, so, I mean, you can do it as both, or as just different, that's fine. So I wonder what way I did at the back. Yeah, I think at the back I did do it as, that it's different. So I will keep it as different, but I just want to say in real life, as like a researcher, you probably will be testing that the hypothesis that there are more people with the blood type B. But it looks like at the back I did it what we first had, which is different. Okay, so that's 5 or more. How far away is that? That's 3 away, isn't it? Okay. What is more extreme? We could have it the other way. But the problem is, you can't be 3 to the left here. Because how many would be with blood type B if you're 3 to the left? -1. So there isn't any extreme values on the left that you can actually consider, because they fall outside the range. Alright, so we're just looking at 5 or more here.
Can't you adjust the percentage?
No. The reason for this is because so few people have blood type B. Like suppose, for example, only 5% of... Yeah, okay, suppose, for example, 10% of people have blood type B, and I have a group of 10 people. How many should have blood type B? 1. Suppose 0 people have blood type B. Does that make me think that this group, they're less than average on blood type B? Not really, because with only 10% having blood type B, it's possible by just dumb chance that that one person wasn't in that group. So my point is, we can't go low enough to convince us, because the percent was so low to begin with. So there is no extreme values to the left here that would convince us, only extreme values to the right. So 5 or more, we can't do or more, so that would be 4 or fewer, which is fine. So we can look up 1 minus table book 20, 0.1 and 4. And what do we get?
1 minus 0.9568.
1 minus 0.
9568.
So, ooh, that's kind of close. That's 0.0432. And that is less than 5%. So we reject the null hypothesis. They got very hard at the end. 11, 12 and 13 were getting a bit tricky. You definitely must be able to do question 1 to 8 for the exam. Definitely must be able to do 1 to 8 for the exam.
11 came off our previous test or something.
Well, an easier version of it. Don't worry, when we do revision, we'll see it.
I'm going to list 1 from the templates.
Huh?
I'm going to list 1 question from the templates.
I did them all in the previous lesson, so you can watch the video. It's on YouTube. I did 1 to 10 actually.
So 1 question, please.
Maybe. It depends on if people want anything from the goodness of fit done. Was there any question in the goodness of fit page that you had trouble with?
You said to do 1 to 6.
I didn't say that quite. I said 1 to 6 would be exam type questions. 7 hasn't been on the exam. Right? I didn't say, Mo, whatever you do, don't do number 7, and for goodness sake, only do 1 to 6. Right? So, were there any questions on the goodness of fit page?
Number 6 was
Number 6 was,
nice.
it was good. But, what was the result? Was it consistent or not consistent? What the heck is my answer for 6? Did I not write it at the back? Huh? Oh, it's like something's messed up here. Oh yeah, it's like I missed the question answer and I'm off by 1, is it? Which answer did I miss at the back for those who've tried it? There's 1 answer missing for 1 question. No. 6 here is 7 and 5 is 6. So between questions 1 and 5 I missed an answer at the back. Which one is it? 1, 2, 3, 4, 5. It looks like I have 5, so it must be 1, 2, 3 or 4.
I think it might be.
Yeah guys, one of my... 4 is missing? The answer? Is it?
It's the same answer.
For which?
4 is rejected. It's not rejected.
So in other words, what 4 and 5 are the same.
Yeah.
So underneath 4 I should have 5. The hypothesis is also rejected. And then where I say 5, that actually begins 6.
So
Yeah.
6, 5 is 6.
5 to 6.
Yeah. It's misnumbered because I missed putting in an answer after 4, is it? After 4 there should be another answer. The hypothesis is not rejected. Yeah, okay, that's fine. So, Yeah, so the answer for number 6 is that, yeah, they do follow Benford's law.
Answer 4, 5, 6 is the same. They're all not together.
Yeah, okay. So what happened, I imagine, is I was copying and pasting, and I didn't paste an extra, yeah. Okay. Right, anyways, is there anything from that page we need to see? Do you know what, actually, before we finish, I think what would be really good is if we open up a final exam and just have a look at what the hypothesis test is on the final exam. So you can just see what level of difficulty it is. So I'll open up last year's exam. You can open it up too on your phone if you want.
So obviously when we're solving this in the class, I can't write it like that in the exam. I have to write more writing. Right?
What I wrote here?
Yeah, like I can't do like write it like this in the exam.
Well, not much more. Like here, rather than just saying 4 or fewer, what was this here? I forget. It was blood type. So just write 4 or fewer type B. And then here, rather than writing table 20.1 and 4, you could write table n equals 20, p equals 0.1, and x equals 4. Just a tiny bit more. Yeah. Right, semester 2, let's have a look at last year's final exam if we can, please. 17, 18, let's see, version 1, if they've got a test in it. It could be in A, it could be in B, let's see. Yeah.
17, 18.
What was the highest grade last year?
Don't remember. Don't remember.
Or the grades good last time.
Don't remember.
Version 1 or 2?
Ah, here we go. Well, it's an example of goodness of fit.
1 or 2.
I'm looking at version 1. But I can see in question B6D, oh, those sons of a guns. B6D. Do you see it? So, you have 100 bulbs, and the claim is the colours are in the ratio of 1 to 2 to 3 to 4. So that means the first one red, the next one white, there should be twice as many, and so on. So you see you have the observed colours, 8, 23, 33, and 36, yeah? What's the expected colours? Who can tell me how many reds you expect to get? Do you remember doing your ratios in primary school?
You need to know one value, so 8 red could be 8.
Yeah, but
You need to know one.
oh, sorry, you can't quite here. Guys, don't make your life difficult. Just tell me here. You have the ratio 1, 2, 3, 4. Yeah. My question is, how do you get the expected values? So what do you do? Say again? Yeah, but how did you get that?
10, 20, 30, 60, 100. The ratios add up to 100.
Yeah, okay. Do you remember how to split a number into a ratio? Your primary school teacher would be disappointed. Okay, so I'll remind you. What you do is you do 1 plus 2 plus 3 plus 4, that's 10. Okay, so this amount is 1/10 the total. This is 2/10, 3/10, and 4/10. So what is 1/10 of 100? Try again. 1/10 of 100.
1
Guys, come on, don't. 10. 2/10? 20. So you are expecting to get 10, 20, 30, 40. Now before we calculate, what do we think? Is what we observed and expected quite similar or quite different?
Similar.
Well, I don't know. If you expected 10 and you got 8, pretty close. If you expected 20 and you got 23, similar. 30 and 33, 40 and 36. Close enough, I think. So, let's do this together. State your hypothesis. What's your hypothesis here? Your hypothesis is that the proportion of colours are in the ratio of 1, 2, 3, 4. That's the null hypothesis. And the alternative is that they are not. 2 marks. How do you get the 2 marks? Have a guess. You get 1 mark for the null and 1 mark for the alternative. Work out the expected colours for 1 mark. So that's working out 10, 20, 30, 40. 5 marks is quite a lot, isn't it? So we do, what's this? 2 squared over 10 plus 3 squared over 20 plus 3 squared over 30 plus 4 squared over 40. So can someone just type that in and let's get this one done. It's positive. You square negative numbers, you get positive.
Because there's a square, so it doesn't matter. 36 minus 40?
Yeah, which is minus 4, but you square it.
I think that's 4 squared.
Yeah.
1.55.
No, it's not. I know the result is the same, but the steps are different.
But I'm so tired, I need to save energy. So if I can spare using the energy to say the word minus.
Put it in the exam as 4 squared.
That would be fine with me. That would be fine. Yeah. What is it, please?
1.55.
1.55. Right. Let's take out our chi-square tables. What's the critical value? Where is it gone? Where is it? I can't find my table. Do you have it there? Let's have a look. Right, so what's the degrees of freedom? What's the degrees of freedom for this question? 3. Now we have to be careful. This is not at 5%. What does the question say to do it at? 10%. So the critical value is 6.25. Right? 6.25. So this 1.55, of course, is much less than 6. What did I say? 6.25. So reject or do not reject? Do not reject. Which you kind of thought so anyways, because we do think that they are in the right proportion. Oh, sorry. What do you ask me? You can't say. Yeah, well, I just wrote down 6.25. Say it again. We don't phrase it like that, but yeah, that's the idea. We say we do not reject the null. Do not reject the null. Which kind of means like we're saying that the null hypothesis is probably true. But that's not a shock result.
That was a B section?
Yeah, for 5 marks. This was 5 marks.
That's really easy.
Well, this is what I'm saying. I didn't say go back up yet. I'm still talking. So back down. This is what I'm saying. The hypothesis testing and statistics can be good, but I always feel like people underperform in it. Now, to finish, I just want to show you the marking scheme for that one there. So what number was this? 6, was it? 5. What was it?
B6D.
6D.
Yeah, B6.
Right, so 1 mark for ratios are as stated. Okay, I would have actually given a full sentence, you know, the colours are in the proportion of 1, 2, 3, 4. and ratios are different. 1 mark for getting 10, 20, 30, 40. Now, 1 mark for using the formula and 1 mark for getting 1.55. If you just wrote down 1.55, I can give you this mark, because this little star symbol means you can assume the student did this if they got the next one right. I mean, they must have. How else could they have gotten this? 1 mark for looking up the critical value, which is 6.25. 1 mark for knowing that 1.55 is smaller than 6.25. And then 1 mark at the end for correctly saying reject. Now, they phrase it incorrectly here. They say we accept the null hypothesis. That's bad English. We don't say we accept the null hypothesis. We say we do not reject it. But if you actually wrote accept the null, I can still give you the mark. Yeah. In other words, Amjad, believe it or not, what I wrote here on my screen gives me the full 5 marks, because I get 2 marks here because they assume that I did it correctly. I get 1 mark here for knowing that it's less than the critical value, which I got from the table book, so that's 4 marks, and then 1 mark for writing this. So yes, I would get full 5 marks for just writing this in my answer book. So this is what I was saying. The statistics question is answered poorly in the exam, which always confuses me because it's quite easy to get marks here. You look shocked. This is how I feel with this one sometimes, okay?
They should prioritize TypeScript for health science students.
They should. And actually, just before you...
No, but
No, that's it, yeah.
statistic questions are either very hard or very easy.
I kind of understand what you mean, but you'll discover after you practice what you think are the very hard ones, is that they actually become very easy. They might be very hard to get your head around, but after doing 10 of them you realise, oh, why did I think this was very hard? It's actually very easy. Like this one here. Yeah. Okay, we have class after lunch, and what are we doing? Quotient rule next. Yeah.